Faceting is one of my favorite features available in ggplot2. Faceting a dataset creates separate plotting panels for each level of one or more discrete variables. Faceting is a useful way for examining patterns for combinations of levels for one or more discrete variables. Technically, faceting can be performed for numeric variables with a relatively small number of unique values, but most of the time, faceting is most appropriate for factor variables. There are two functions for creating faceted graphics in ggplot2. Facet_wrap facets the plots based on a single factor variable, and the panels are wrapped around the plotting window, whereas facet_grid forms a matrix of panels based on row and column faceting variables. So usually if you use facet_grid, you have two faceting variables, whereas facet_wrap is typically used for a single faceting variable. Let's do an example with the penguins data where we facet a scatter plot of bill length versus body mass with respect to species, a single factor variable. You can see here that we use the facet_wrap function to facet around the species variable. The resulting plots are shown below. Notice that by default, the x and y axes of our scatter plots are the same across all panels. This is standard in ggplot2 because it facilitates direct comparison across panels. However, this can be customized depending on your needs. Specifically, you can use the scales argument of the facet_ functions. The allowable scales arguments are fixed, which means the same x and y axes for all panels, which is the default shown above. Free, which means to specify individual x and y axes for each panel, in which case you can't make any kinds of comparisons across panels. Free_x, which means that each panel has individual x-axes but a common y-axis, and free_y, where we have individual y-axes for each panel but a common x-axis. We're now going to use the facet_grid function to facet our plots by two factor variables, species and sex. Notice that prior to plotting, I'm going to remove any of the observations with an NA for the sex variable in order to simplify my plots. That's what this subset function is doing right here, though I'm not going to explain it in detail. The main distinction between what I had before with respect to the scatter plot and faceting is that I now use the facet_grid function and I facet by two variables, species tilde sex, which means I'm going to facet by species on one axis and sex on the other. You can see in the graphic below that we facet by species. We have Adelie penguins in the top row, chinstrap penguins in the middle row, and gentoo penguins in the bottom row. Additionally, we facet by sex equals female in the first column and sex equals male in the second column. This allows us to see the relationship between body mass and bill length with respect to both sex and species in our data set. Notice that there does appear to be differences in the size of the male and female penguins, but it's a bit difficult to compare the patterns across the different panels. So in this particular example, I actually would not facet by both species and sex. Instead, I would facet with respect to species using colors or shapes in a single panel. That's what I've done in this plot here. You can see here that I've used facet_wrap to facet by species in my plot, but then in my point geom, I have specified color equals sex and shape equals sex, so that I use both color and shapes to distinguish between the female and male penguins among each of the species. This makes it even more clear that in general the male penguins are larger than the female penguins. And that relationship holds for each one of the species, though body mass and bill length vary quite a bit across the different species.